So Henry Sagerman is an impossible act to follow. And unlike him, I might need an introduction. So here's a brief introduction to the things I care about: math, math education, folk dancing, languages, especially Japanese. I love to talk to people, so come talk to me about any of those things. In French, the 15 puzzle is known as Jeu de Taquin, which means the teasing game. And it inspired a combinatorial version of Jeu de Taquin. So again, we've got slightly different rules. My two favorite things that I found out about the 15 puzzle lately are that you can find a clip of Johnny Carson, of Bobby Fischer, the great chess champion, on Johnny Carson doing the 15 puzzle in 17 seconds, which seems a little slow. I mean, it should be 2 seconds faster, right? But he's way faster than Johnny. And then this was a huge craze in the 1880s, and pundits were complaining about how people were not, teachers weren't paying attention to their students, or pastors to their flock, because they were so busy sliding these tiles around. And I thought, and in particular, they weren't paying attention to the election of 1880, which was a very close election between Garfield and Hancock. And I was wondering if we could maybe find a puzzle at this meeting that would keep me distracted for the rest of this year. But for the math version of things, so here's instead of dealing with things on a rectangle or some other interesting surface, we'll just be in the plane. We've got straight shapes that are top and left justified. And we've got these skew shapes, which are the difference of two straight shapes. And the numbers have to be put in a way such that they're always increasing from left to right and from top to bottom. Those are the rules. So we'll never allow any slide that violates that rules. And just to give you a sense for what's going on is think of the red square here as the whole. The blue squares are frozen for the moment, right? And so I can slide either the 1 up or the 2 over, but sliding and you can see this, good. But sliding the 2 over would violate the tableau rule, so I have to slide the 1 up. Right, then the hole is moved down here, the red tile is moved down here, so now I either slide the 6 up or the 5 over, but it has to be the 5. So unlike the game, I no longer have free will over how I move the tiles around. It's more deterministic. And then finally here, the 8 has to slide up. And then the square at the boundary, I might do something with it depending on the game, or I might just forget about it and say, okay, there you are. That's the new tableau. So I'm going to tell you 2 amazing facts, and there's a bonus set of slides I'm sure I won't get to. So confluence. So if I have this skew tableau here, and I want to convert it to a straight shape, then there are multiple ways I can do it. I don't have any choice in individual slides, but in sequence 1, I start with this green square, and I slide into it. And then I have to slide into I don't have any choice. I have to slide into this square, then this square, then this square, successively in order to be sliding into a legal place. In sequence 2, I slide into this upper right green square first, and then I slide into the next one over, and then I slide into this one and then to that one. And you'll notice that I end up getting the same answer at the very end. I get the same straight shape no matter which sequence of slides I do. So think about that for a minute. I don't think it's obvious. One of my practice listeners thought it was pretty amazing and wanted to stop and just think about that for the rest of the talk. So feel free if that's what you'd like to do too. There's 2 different ways you could slide this, or more than 2, but these 2 different ways give the same result. But if I were trying to slide, for example, into a shape with 1 empty square left in the upper left-hand corner, I wouldn't get the same result at all, because you can see that the penultimate shapes are different. Okay, so that's one amazing thing that's easy to explain. Now here's another game that we play, and all of these games are useful in the mathematics of representation theory and algebraic geometry. We don't have time to get into any of that. So in this game, I look at the smallest labeled thing, and I slide it to the other side. I pretend that it's the whole. So I slide the 2 over, and then I slide the 4 up, and this thing which I'm still labeling with a 1, even though it's sort of empty, goes on the boundary and gets frozen. And then I take the 2, the lowest labeled thing, and I slide it. So the 3 comes up, the 6 comes up, the 1 isn't participating. So now I have the 2 on the boundary, and then it freezes. And I just keep doing this step by step until I end up with a tableau, except it's not really a tableau because I violated the rules. But in this tableau, it's always decreasing strictly, going to the right and down. And so I can just reverse the order on the numbers. So 6 becomes 1, 5 becomes 2, and so on. And I get a legitimate tableau. So this is an operation that takes me from one of these tableaus to another tableau. And then if I could take that same output and put it into this input and see what happens, and there I am, I do it, and I end up getting back where I started. And that wasn't just a random accident. That always happens. So this evacuation map is its own inverse. You apply it twice, you get the identity. And again, this is something that takes a little while to prove, although maybe there's a slick G4G proof that nobody's thought of before. Does anybody know what FTWK stands for? For those who know? So this fact generalizes to linear extensions of any finite poset, for those who know. And I found, my advisor, Richard Stanley, is giving a talk later, and he's written a very useful expository article that you'll see about this. He has a student named Lauren K. Williams, but it's not this Lauren K. Williams. This is a different one who happened to do an applet on a Jeu de Taquin tableau. And so that's something if you want to play around with it. I also have used her two-dimensional linear transformation applets with my sophomore linear algebra students. And then here are the references where you can find out more. Please come talk to me. Thanks for your attention.